Parametric equations. Sometimes we write a function in terms of parametric equations where both x and y are given in terms of a third variable, t. So we have something like x equal f of t, y equal g of t. Each value of t gives us a point xy. T is often used because t represents time, and this is convenient for many physical experiments. We can interpret the point xy equal f of t, g of t as the position of a particle at time t. Let's try an example. Sketch and identify the curve defined by the parametric equations x equal t squared minus 2t and y equal t plus 1. So let's just pretend for a moment that we have no idea what this looks like. So if you don't have a clue what to do, you make a table. And we just plug in particular values for t. I don't know, let's start with our favorites. -2, -1, 0, 1, and 2. And we'll do more if we need to. So when t is -2, x is -2 squared, which is 4, minus 2 times -2, so I get what, 8? Y is -1. When t is -1, for x I get -1 squared, which is 1, and then -2 times -1 is a positive 2, so I get what, 3? -1 plus 1, I get 0. If t is 0, x is 0, y is 1. Let's see. If t is 1, x is 1 minus 2, so it looks like -1. And y is 2. Let me scroll a little bit. If I plug in 2 for x, I get 4. I get 0. Okay. And then if t is 2, y is 3. Let's keep going, see if we can find a few more. Plug in 3, we get 9 minus 6. Look like that's 3. And y is 4. If I plug in 4, I get 16 minus 8. I get 8 again. Okay. And I get what, 5? And if t is 5, we'll stop at 5. I get what? 25 minus 10, 15. And 6. Okay, so this is a good starting point. Let's just plot these points. Let's plot just the x and the y. X is 8. 1, 2, 3, 4, 5, 6, 7, 8. Y is -1, so there's a point right there. 3 and 0. Right here. 0, 1. -1, 2. 0, 3. 3, 4. 8 and 5, and so on. Okay, so we have a sideways parabola. Here's t equal -2, t equal 1, t equal 0. Sorry, t equal -1 right here. T equal 1, t equal 2, t equal 3, and t equal 4. And if I continued, we go along this way. So we can draw arrows on this curve in the direction of increasing t values. Notice this has no beginning t, no end t, so it goes on forever and follows this curve. Let's see if we came up with the same thing if we were to do it algebraically. Okay, so let me rewrite my functions. X is t squared minus 2t, y is t plus 1. Let's use algebra. So let's solve this for t. T is what? Y minus 1. And I can make a substitution for those t's right there. So x is, looks like y minus 1 squared minus 2 times y minus 1. So that's y squared. We know that a minus b squared is a squared minus 2ab plus b squared. So this is y squared minus 2y plus 1 minus 2y plus 2. So x is y squared minus 4y plus 3. Okay, we see when y is 0, x is 3. That's like my vertex right here. And we can find intercepts if we want to. So we found the x-intercepts here. Let's find the y-intercepts. That means x is 0. So y is 1, y is 3. We have the points 0, 1, and 0, 3. That's what we had up here. Perfect. So we know this is a sideways parabola centered around the positive x-axis. And if you forget that, you can always just take a second and recall that if y equal x squared centered around the positive y, then x equal y squared is a parabola, but this time it's centered around positive x. So you can think about graphing y equal x squared minus 4y plus 3 and then twisting it. Okay, but do we see that I could come up with the same equation algebraically, or I could plot a whole bunch of points? Particle whose position is given by these equations moves along the curve as t increases. So it's very important we draw our arrows in the direction of increasing t values. T can express any real number, but sometimes we want to restrict t to a finite interval. So let's look at our equations again. We had x equal t squared minus 2t, y equal t plus 1, and now we have a restriction on t. We say that t is between 0 and 4. How does this change our picture? We're going to have the same kind of graph, but now we're only going to start at t equals 0. So t equals 0. We had 0, 1 when t was, 1? We had negative 1, 2. When t was 2, we had 0, 3. When t was 3, we had, 3, 4? And when t was 4, we had 8, 5. So this is the same thing I just rewrote, part of my table, just on this other page. I'm only interested in from 0 to 4, so I just rewrote those values, and that's all I'm going to plot now. Okay, so 0, 1, negative 1, 2, 0, 3, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 5, like this. Starting here and stopping right there. So this has a beginning point and an end point. So this was t equal 4, this is t equals 0. It doesn't go beyond those values, but it goes in this direction in between them.